Hello everyone, this is Shrawan Sir making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today we are going to solve one of the most important questions from sequence and series, which is from Optional Math class 10. Here we go. Dear students, the question is the third and sixth and 12th terms of an arithmetic progression are in geometric progression. Calculate the common ratio of the geometric progression. Dear students, in this question we are given three terms of an arithmetic progression: third term, sixth term and 12th terms. All these three terms of an arithmetic progression are in geometric progression. Now, according to the question, we have to find out the common ratio of the geometric progression. Dear students, the third term in arithmetic progression is given by the formula a plus 2d. T3 we can write as a plus 2d. The sixth term we can write as T6 equals a plus 5d, and T12, that means 12th term, we can write as a plus 11d. Dear students, we know that the general term of an arithmetic progression is given by the formula Tn equals a plus n minus 1 times d. Dear students, to get the third term, we have to put the value of n equals 3. Then a as it is, n means 3 minus 1 and d means as it is. Dear students, by using the formula of general term of arithmetic progression, that means Tn equals a plus n minus 1 into d, we can find out any specific term. By putting the value of n equals 3, we can get the value of T3. The value of T3 is a plus 3 minus 1. That means 3 minus 1 means 2, 2 times d. So dear students, the formula of T3, that means the third term of an arithmetic progression, is T3 equals a plus 2d. So we can directly write down the formula of any term by putting the value of n in the general term formula. We can get any term of arithmetic progression. So dear students, T3 we can write as a plus 2d by using the formula of general term of arithmetic progression. Similarly, T6, if we put value of n equals 6 in the formula of general term of arithmetic progression, then we get T6 equals a plus 5d. Similarly, we can get T12, that means 12th term of the geometric of the arithmetic progression. The value of T12 will be 12 minus 1, that means a plus 11d. So dear students, according to the question, we are given three terms of an arithmetic progression: T3, T6 and T12. So T3 we can write as a plus 2d, T6 we can write as a plus 5d, and T12 we can write as a plus 11d. Dear students, now according to the question, the three terms T3, T6 and T12 of an arithmetic progression are in geometric progression as well. So according to the definition of geometric progression, if the terms are in geometric progression, then the common ratio are equal. So if we take the common ratio of T3 with T6, that means T6 divided by T3, T6 divided by T3, and again T12 divided by T6. Dear students, according to the definition of geometric progression, a sequence, or we can say a progression, is a geometric progression if the common ratio are same. So the common ratio of T3 and T6 we can write as T6 by T3, and again the common ratio of the other two terms we can write as T12 divided by T6. So this is according to the formula of common ratio of geometric progression. We know the common ratio of a geometric progression is given by the formula r equals t2 divided by t1. That means if we divide any succeeding term by its preceding term, then we get the common ratio of geometric progression. So according to the question, the three terms t3, t6 and t12 are also in geometric progression. So the common ratio must be equal. If these three are in also geometric progression, then the common ratio must be equal. That means t6 divided by t3 is the common ratio. Again t12 divided by t6 is the common ratio. Now let's put the value of the corresponding terms. The value of t6 is a plus 5d divided by t3. t3 is equal to a plus 2d. So this is by putting the value of t3, t6 and t12, and by solving it we'll get the relation between a and d, and after getting the relation between a and d, we'll put the value in the common ratio t6 divided by t3, or we can put the value in t12 by divided by t6. Then we'll get the value of common ratio, which will be the required answer. So dear students, let's put the value of t12. t12 means a plus 11d, a plus 11d divided by t6 means a plus 5d, a plus 5d. Dear students, now by solving this equation we'll get the value of a in terms of d, or we'll get value of d in terms of a. So let's do the simplification. Let's solve this equation, or let's do cross multiplication at first. A plus 5d into a plus 5d. So a plus 5d times a plus 5d. So after cross multiplication we get a plus 5d times a plus 5d equals a plus 2d, a plus 2d times a plus 11d. So dear students, in order to solve this equation we have to do cross multiplication. So after cross multiplication we have got a plus 5d times a plus 5d equals a plus 2d times a plus 11d. So let's solve it further. Dear students, now let's do the multiplication. A times a, we get a square, plus a times 5d, we get 5ad, plus 5d times a, we get again 5ad. So simply we have to do the multiplication. 5d times 5d, we get 5 5s are 25d square equals to, now let's multiply the expression of the right hand side. A times a, we get a square, plus a times 11d, we get 11ad, plus let's multiply by the second term, 2d into a. 2d times a, we get 2ad, plus 2d times 11d, we get 11 to the 22, and d times d, we get d square. So dear students, we have multiplied the expression of the left hand side, and also we have multiplied the expression of the right hand side of the equation. So dear students, now a square and a square, both sides they are equal, so we can cancel the equal terms. 5ad plus 5ad, we get 10ad, plus 25d square, keeping as it is, plus now on the right hand side 11ad plus 2ad, we can write 13ad because they are like terms. So by adding 11ad and 2ad, we get 13ad plus 22d square. So dear students, now the smaller terms will move towards the greater terms. So greater terms, we have 25d square as compared to 22d square. So keeping the like terms on the same side. So 25d square minus 22d square. So we have shifted 22d square towards the left side. Now 13ad. 10ad moving to another side, we get minus 10ad. So dear students, 25 minus 22, we get 3d square equals 13 minus 10, we get 3ad. So dear students, we can cancel now 3 we can cancel, because 13 minus 10 we get 3, and again 25 minus 22 we get 3d square. Again we can cancel d and d, because the common difference cannot be 0 in arithmetic or in geometric progression, so we can cancel d on both sides. Then we get the value of d. The value of d we get equals to a. So dear students, by solving this expression, we have got a relation between a and d. A means the first term and d means the common difference of the given arithmetic progression. So dear students, now we know the value of a is equal to d. So according to the question, now the common ratio, we have to find out the common ratio of geometric progression. So let's find out common ratio. So dear students, common ratio is equal to, the value of common ratio is equal to T6 divided by T3. Dear students, common ratio is R equals T6 divided by T3. T6 divided by R means T6 divided by T3. Dear students, if we put the value of T6 and T3, then we'll get the common ratio. T6 means A plus 5D and T3 means A plus 2D. So dear students, the value of A already we have got equals to D. So now we'll put the value of A, we'll replace the value of A by D or the value of D by A. So if we replace the value of D by A, so this A as it is plus 5. The value of D is equal to A. The value of D is equal to A divided by A plus 2. The value of D is equal to A. So again putting the value of D equals A. So dear students, now 5A plus A we get 6A, and 2A plus A we get 3A. So by cancelling this, we get the value of common ratio, that means R equals to 2. According to the question, we are given 3 terms of an arithmetic progression, T3, T6 and T12, and those 3 terms of arithmetic progression are also in geometric progression. So if T3, T6 and T12 of an arithmetic progression are also in geometric progression, then the common ratio must be equal. According to the definition of geometric progression, the common ratio are always equal. So common ratio means T6 divided by T3, succeeding term divided by preceding term, we get the common ratio. And again T12 divided by T6, we get the common ratio. So by equating the value of common ratio and substituting the corresponding value of T3, T6 and T12, and by solving it we get the value of A equals to D. So after knowing the value of A equals D, we can find the value of common ratio. The value of common ratio means T6 divided by T3. So T6 means A plus 5D and T3 means A plus 2D. The value of D, we have got A. So replacing the value of D by A, we get A plus 5, A, that means 6A divided by 3A. So if we cancel A and A, then we'll get 2. The value of common ratio is 2. Thank you for watching this video. I hope you have understood how to solve the problem of arithmetic and geometric progression. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.